Greetings, everybody. I think it's time that we start talking about derivatives of logarithmic functions. Okay, and I think this is a good example to do because I can show you how to solve it in a way that I think it would cover a lot of different scenarios that you might see for logarithms. Okay, so here goes. It says, can you find the derivative with respect to x of natural log of x plus 2 over x minus 2? Okay, so that's our initial prompt. So I give you two methods. I'll discuss the differences between them, and I think in the end, it's up to you how you want to solve it, but it would be good to hear me out on both methods, okay? Because I think through either method, through at least seeing it, you can learn more about how you would solve this kind of problem in general, even if you chose one method over the other. So here's my first method. And this is the one I would use. This is how I would work it if I saw it. I think what we should do is simplify this function in there using algebra, okay? And then after we do that, we calculate the derivative on the simpler function. All right, now I say algebra, and the reason I say that is because when you learn algebra, you'll start learning about logarithms, and there are lots of rules for logarithms. One of them says logarithm base b of m over n is the same thing as logarithm base b of m, then minus logarithm base b of n. Okay, so you might think of it as any logarithm of one thing divided by another thing can be split up into subtraction. Okay, and what we have here, this ln, that's the natural logarithm. That's a logarithm of base number e. Okay, so e is about 2.718. It's a special number we use for compound interest calculations, radioactive decay, population growth. We use it for lots of things. So I think that would be the preferred method, and what I'm going to show you in method 1. So by this rule, natural log of x plus 2 over x minus 2 is equal to natural log of x plus 2 minus natural log of x minus 2. Okay, so let's consider that the reduced simplified form, and I'll find the derivative of that. Okay, so the derivative with respect to x of natural log x plus 2 minus natural log x minus 2. So the rule for that would be this. Okay, so now we're doing calculus. We're finding the derivative. And there's, for different kinds of functions, the rules for derivatives are different. Okay, the derivative of natural log of u, where u is some function, some formula that has x in it, is 1 over u times du over dx. Or you might say, if you want to, 1 over u times u prime, or 1 over u times the derivative of u. So that's what I'll use when I find the derivative of this. So let's look at it one term at a time. What's the derivative with respect to x of natural log x plus 2? By this rule, it would be 1 over x plus 2 times the derivative of x plus 2, which is 1. So it's 1 over x plus 2 times 1. Then I carry this minus into my result. And the derivative of natural log x minus 2 is, with the same rule, 1 over x minus 2 times 1. Okay? All right. And I guess I wrote those ones to show you how it matches up with what this rule says to do. The ones in each case are the du over dx. But we don't need to leave them there, and we could give this as the answer. Now, I noticed, though, that that's not the answer that we see in this question as I copied it from the assignment on my math lab. But that's okay. It's easy to show it's the same thing because these are fractions which can be subtracted so long as we get a common denominator. That common denominator between these is x plus 2 times x minus 2. So I take this first fraction, multiply top and bottom by x minus 2. And then I take the second one, multiply top and bottom by x plus 2. And I get like so. Combining into one fraction, it's going to be x minus 2 minus x minus 2, giving you negative 4 over x squared minus 4. Okay, and then that is in fact the answer that we see on my math lab. So that's the first method that I want to recommend, and that's how I would do it. I think it's the easiest method for solving this one if you're going to solve it with paper and pencil. there is another way. And so let's do like this. Let's consider the second method. Could we just, you see how there's this rule for the derivative of a natural logarithm? Okay. Why can't we just use that rule directly? Like, in other words, like, what if we don't simplify it first? Can we use this rule that I just showed you for the derivative of a natural logarithm just right from the beginning? Okay, so you can do that. Remember that rule, the derivative of natural log of u is 1 over u times u prime. Okay, so I get the derivative with respect to x of natural log of x plus 2 over x minus 2. That'd be 1 over x plus 2 over x minus 2. And then this part would be the derivative of x plus 2 over x minus 2. So what you're looking at here is 1 over u times u prime. But how do you find the derivative here? How do you find the derivative of x plus 2 over x minus 2? Well, that all by itself is the quotient, and we'd have to use the quotient rule to find the derivative. So here, what you're looking at is the quotient rule derivative of x plus 2 over x minus 2. So okay, I get like that. You see here for this part, I'll say when you divide by a fraction, that's the same as multiplying by a reciprocal. So 1 over x plus 2 over x minus 2 is x minus 2 over x plus 2. And then this part I could simplify to negative 4 over x minus 2 squared. Okay. To go to the next step, I notice some canceling can be done. I get an x minus 2 here, and then I have two factors of x minus 2 here. I can cancel one of those pairs. I would turn this into a 1, and I would turn this into just x minus 2. And then I got these two fractions which are multiplied. How do you multiply fractions? You multiply straight across. So I get 1 times negative 4. I get negative 4 there. X plus 2 times x minus 2 is x squared minus 4. So that's the same result as the other way I showed you in the question on my math lab. All right, same answer. Like, what good would it be if you didn't get the same answer for either method? Now, I think this method is harder. You have to use rules layered inside of each other. First I have to use this overall rule for the derivative of a logarithm, but then when I'm working inside of that, I've got to use the quotient rule, and it seems like more to simplify, but that's just my opinion. All right, which method should you use? I guess, like, at this point, I'd like you to consider both methods I showed you, but then whichever one you feel inclined to use, you can get either one to work. You see, either one of them worked. They both got me the same answer in the end. So I guess, although I think this first method is simpler, it doesn't really matter how you do it. I hope, though, for now you considered both methods, that you heard what I had to say for each of them, because no matter which one you pick, I think you can learn something from the other one that might apply to other problems you see in the assignment.